This is example 13.2 in Discovering Design with Chemistry. And it says a 45.9 gram sample of an unknown metal is heated to 89.7 degrees Celsius and dropped into a calorimeter that contains 150 grams of water. The initial temperature of the water is 25 degrees Celsius, and by the end of the experiment, the temperature increased to 29.6 degrees Celsius. What is the specific heat of the metal? And we're told to ignore the heat absorbed by the calorimeter. The reason we're told that is because when we use this equation in our problem, we can just pretend this one doesn't exist and just understand that the liquid and the object just traded heat, if that makes sense. Okay, so I'm going to go ahead and mark that one out so we can remember that. So let's start labeling the pieces we know, because this problem had a lot of words and a lot of numbers. So this is the mass of our sample, and it's heated to this and then dropped into a calorimeter. So this counts as our initial temperature because it's the temperature where our problem starts, not necessarily where the metal thing was earlier before it was heated. Our problem starts at it being heated already, so that's our initial temperature. And then we get some information about the water. So I'm going to change colors. Let's do this one. So this is the mass of the water, and then we have the initial temperature of the water. So here's our T of I. Oh, that's hard to read, but I think you can see it. And then we have the final temperature of the water, which, by the way, because at the end of a calorimetry experiment, the temperature of the liquid and the calorimeter and the object are all going to be the same. That final temperature is. And so this is also the final temperature for our metal too. And then it wants to know the specific heat of the metal. And so this is going to be our C is what and that's what we want. We want to find what is C. So C is in this equation. So we know we're going to be using that equation. But we've got two things we're working with here. We know the mass of the metal. They want the C of the metal, but we don't have all the pieces that we need in this case. And so we're going to make sure that we have everything lined up. Okay, so let's start with working on the finding our Q's. So we're going to do the change in temperature for the water first. So change in temperature for the water. So we're going to start with the final temperature. And we're going to subtract the initial temperature. I'm going to make my font smaller in the middle, but I wanted the problem big so I could write all over it. So when we subtract those two, we get 1.9 degrees Celsius, and that's the change in temperature. And I'm going to write water so we can remember, even though I'm using a color-coded system on your paper. If you're just using I really should write liquid, but in this case they told us it was water. And precision subtracting, we're to the 10th place, we keep it to the 10th place. So now we have all the pieces we need to find the information about our Q for our water. So Q equals the mass of the water, that's 150.0 grams. Our C for water, this is something that we are supposed to have memorized, so 4.184, and that's joules per grams times Celsius. And then our change in temperature for the water is 1.9 degrees Celsius. Now looking at this, I can see that I'm going to have to limit this to two significant figures. So I'm going to write that over here kind of near my problem with the little bubble around it so I can remember what I'm going for. So let's pull up the calculator. And we have 150. I can write the 0.0, but my calculator is going to give me the same answer. So I understand significant figures in working, but in the calculator, I don't include the extra zeros because it won't change anything in my calculator. All right, we only get to keep two of those. So that's the thousands place and the hundreds place are the only two. So we're going to use that 9 to round up. That's going to be 1200. So, and these numbers they're all positive, so our answer is also positive. So 1200 joules. That's how much energy the water, or how much heat the water gained. And so now that we have Q of the object, we can find out its specific heat capacity. The reason we couldn't just jump to that to begin with and just jump straight to this equation right here and find the C that we wanted is because we had the mass and we have the change in temperature, but we didn't have the Q. And so we know that using this equation right here, if we have the Q for one thing, we can find the Q for the other thing. Or if we weren't supposed to ignore the calorimeter, we would need the Q for two of the things to find the Q for the third thing. Okay, so let's scoot this up just a little bit. So we now have, this is, oops, no, let's use the right color. So this is Q, and that's Q for our water, or Q for our liquid. All right, so we have, let's use an in-between color. All right, so the negative Q of, in this case, the metal, I'm going to write metal instead of object, equals the Q of our liquid, which in this case is water. And we don't have to worry about the calorimeter because they told us not to. So because we want this one, we don't want the negative version of this one, I'm going to multiply both sides by -1 and write Q of metal equals negative Q of water. And then I'm just going to put in that number. So negative, and what is the Q for our water? It's 1200 joules. In other words, the Q for the metal is negative, 1200 joules. All right, so now we have the thing that we need. This number right here is the Q. So now we have the Q, we have the M, and we can get the change in T. Let's go ahead and do our change in T. So we have that. So our initial temperature and our final temperature are what we need. So let's do it over here. So change in T, we start with the final and we subtract the initial. Our final temperature for the object is the same as the final temperature for everything else. That's 26.9. And then our initial temperature was 89.7. So we're going to subtract, I left a T out. We're going to subtract those two, and you can see it's going to be negative. Again, we have to keep our precision the same when we're adding and subtracting. So if significant figures keeps it to the 10th place because they're both to the 10th place. And so we get 62.8 degrees Celsius. So we now have all the pieces we need to find C. Now, because I'm going to use this, let's pick another color. Actually, blue might make me think of water. Let's do green. Okay, so in this equation, Q equals MC, change in T, we're going to use that to find our C, but I want C to be by itself. I want it to be C equals something, so I don't have to rearrange. I can just plug in all my numbers. So C is opposite Q, and the things that are with C that I want to get rid of are M and change in T. So I'm going to put those on the bottom. I just divided both sides by mass and both sides by change in temperature, which made it go away on the right, and it ended up on the bottom on the left. And then, of course, I wrote it with the C on the left so that it looks like how I want it to be seen. All right. I try to mention some basic algebra stuff in case algebra is not your thing, but I also assume that you know some algebra, so I don't have to go too deeply into that. All right, so C equals Q over M, change in T. So the Q that we just got, that's this one. That's the Q for our metal. So we're going to start with that. So negative 1200 joules. And then our mass, that's up here. So that's 45.9 grams. Make that a little bit longer. And now we're going to put in our change in temperature, which we just found, which is negative 62.8 degrees Celsius. All right, let's check our units. We're going to end up with joules over grams times Celsius, which is perfect because that is how C usually is written. So let's go ahead and write that. That way we're all ready. Okay, we have a negative and a negative, so when we divide those are going to be positive. Our answer is going to be positive. And so I'm not going to type in the negatives in my calculator. I just figured that out without the calculator, so I don't have to deal with it. So 1200 divided by, let's put the two bottom numbers in parentheses, 45.9 times 62.8. All right, so the number I get is this really long decimal, and I should have written down the significant figures before, but I didn't, so let's just look at them to the side. We have 1200 on the top. Only the 1 and 2 are significant, so we have 2 there. The numbers on the bottom each have 3 significant figures, so we're limited to 2. So I get to keep just that much rounded. So the 6 will make it round up to 0.42. So 0.42. And I already have my units written. So I didn't have to worry about that at the end. And did that answer our question? What is the specific heat of the metal? Yes. This is C, and it's the specific heat. In fact, I probably should have written, like, instead of writing C over here, I should have written C of metal here instead of just a plain C. All right.